Temperature and measurement. Temperature is a measure of the average kinetic energy of the particles in an object. Kinetic energy is the energy of motion or movement. It tells us how fast the particles are moving and how much energy they have because of their movement. The faster the particles are moving, the higher the temperature. The slower they're moving, the colder the temperature. And in the illustrations you can see on the left, the short arrow indicates slow movement. These particles are not moving around very fast, and so it's a cold substance. On the right, the long arrow indicates faster movement, more movement, and so this side on the right is a hotter substance. Heat always moves from hot to cold. So in the picture on the bottom, you can see the direction that the heat energy is moving. And when there's kind of an evening out, when there's the same amount of hot and the same amount of cold in an area, we call that thermal equilibrium. There are 3 temperature scales that we use. They are the Fahrenheit scale, the Celsius scale, and the Kelvin scale. And we'll talk about each of those independently. First, the Fahrenheit scale. This is what we use in the United States. It's based on the lowest temperature that Daniel Fahrenheit could achieve with something called brine, which is a mixture of ice, salt, and alcohol. And the very coldest temperature that he could create with this brine he called 0. And then he moved up from that and he noticed that water started to melt at 32 degrees on his scale. Also, water freezes at 32 degrees on his scale. And then he continued up and he noticed that water would boil or change from a liquid to a gas phase at 212 degrees on his scale. There are 180 degrees between freezing and boiling points of water on the Fahrenheit scale. The Celsius scale is a little different. It was created by a man named Anders Celsius. Sometimes it's also called the centigrade scale. This scale is based on the freezing and boiling points of water, so it's very user-friendly. It's used by most of the world and by scientists. This is considered by some people to be an SI unit. There are 100 degrees between the freezing and boiling points of water. So Anders Celsius decided he was going to make an easy scale to use, and water always freezes at the same temperature, so he said that would be 0. And water boils at sea level at the same temperature, and so he said that would be 100. The Kelvin scale is different yet. In the Kelvin scale, we don't say degrees Kelvin, but just kelvins. So if I wanted to say the melting point of ice is 0 degrees Celsius, I would say it's also 273 kelvins. It's based on the idea of absolute 0, which is the coldest possible temperature. This is the point where all the motion of the particles in an object have totally stopped. It's believed to be impossible, but in theory, this could happen. We just haven't observed it yet. So what happened here on the Kelvin scale? Absolute 0, where all the motion in the particles in an object stops. Totally frozen. We call that 0. And then we move up the scale and water freezes and melts 0 degrees Celsius, but that happens to be 273 degrees Kelvin, or 273 kelvins. Continuing up the scale, water boils at 373 kelvins. So it's the same gap there of 100 degrees. Because the 0 point is absolute 0, you can't possibly get any colder. The Kelvin scale has no negative numbers. This is the official SI unit for measuring temperature. It's the same size degrees as Celsius. It just starts at a different place. And scientists use this, but really nobody else does. Here you can see a comparison of the boiling point, freezing point, and absolute zero on the 3 different temperature scales. And here are some everyday temperatures that we might be familiar with. The human body temperature in Fahrenheit is 98.6 degrees. What is it in Celsius? How about Kelvin for body temperature? Room temperature in Fahrenheit is 77 degrees Fahrenheit. It's a comfortable temperature. What is that same temperature in Celsius? What is it in Kelvin? The freezing point of water is 32 degrees Fahrenheit and 0 degrees Celsius, 273.15 kelvins. Absolute zero is what Kelvin scale is based on. What are the absolute zero temperatures for Celsius and Fahrenheit? Which scale do you think is the easiest to use based on what you know right now in your observations?